Well, thanks, Luke, for that, and thank you to Tech Leaders to invite me to this talk, to give this talk. Yes, that image is AI generated as well, so I thought I would start from there. So hello, my name is Ajay, and I am the Director for Building Digital UK, Director for DDAT, not the Director of the whole thing, where we are an executive agency of the Department of Science, Innovation, Technology, and our remit is to connect the whole of the UK to gigabit broadband capability. So we are here to connect the whole of the UK, in short. In terms of my background, I've been dabbling in AI and data science for the past 20 years. So before this, I was in national security. I was the Chief Science Officer and the Chief Technology Officer of Counterterrorism Policing. And before that, I was in Defense Science and Technology Laboratory, also known as DSTL Porton Down, where I held several different roles. One of them was the Chief Scientist of the AI Lab, and I was in academia before that. So I specialize in semantics, which is all about associating meaning with data. So that's my background in short. So let's go to BDUK. So as I said, executive agency of DSIT, and our goal is to connect the whole of the UK. We've got two programs for that. One of them is called GIS, or Gigabit Infrastructure Subsidy, which is basically about laying cables all across the UK so that you get that gigabit-enabled broadband capability. So we've got £5 billion of funding for that. The second one's called SRN, or Shared Rural Network, which is about providing 4G capability. And there's a further £1 billion for that. So it's a £6 billion program in total. And you'll see our corporate objectives over there. I'm not going to read all of that, but if you look at Objective 5.1, develop practical digital solutions to support the delivery of the program, that's where I come in, so that's my remit. In terms of what we've gotten so far, so we've published our annual and accounting report, which you can download from the web, just search for it. But you'll see that we've achieved quite a bit already. So as of 2024, 4,000 square kilometers covered via 4G with the SRN network. And if you look at the GIS program, over 1 million premises passed, 7 procurements live as we speak. So you may ask, okay, so if the private companies are doing the internet connectivity already, so what the hell is BDUK doing? So where we come in is we are not the ones laying the fiber in the ground. So what we get is we get lots of connection information from all the commercial suppliers to say where in the country are they connecting the premises to. And we need to figure out where the hardest to reach places are, so the remote part of Scotland or a village in Wales, for example. So we need to figure out where is it that the commercial suppliers aren't going to, and that's where we provide the subsidies. So if you think about it, BDUK is a infrastructure organization, but we're actually a data organization because the way we make our decisions is completely based on data. So we receive extremely complex data, highly structured data, from all across the country, from all different suppliers. We need to figure out what our strategy is for intervention based on the connection data we receive. So it's a huge data problem, and we love it because we like data. So I'm going to get into AI in a bit because you need to sort your data out first before you get into AI. So that's the whole point of my talk. That's enough about BDUK. So let's go next. As CTOs, of course, we're always asked, what are your big bets in AI? So of course, I'm going to lay down my big bets as well. I'm not going to go into a lecture about each one of these because that's going to take several hours. But instead, I'm going to focus on the things which excite me the most. So what have I seen recently which is most exciting? So the first thing is optimization of back office functions. So we all know about death by Excel. Everyone's got spreadsheets. We don't like them. We want to store them in databases. And there's lots of back office optimization which needs to be done. So agentic AI, yes, there's all the flashy stuff, but some of the most important stuff is often the boring AI, which actually helps you. So the back office functions, usage of agentic AI for that is one of my big bets, and I think it's going to happen. The second thing is media and creative arts. You've all seen AI-generated imagery, video generation, all sorts of things. So that's where I think it's completely going to change the production space. Omni-human, I think, is the latest model where you just need to provide it one single image and a minute of their voice, and it can animate the image, not just the face, but it can animate hands and everything else as well. So it can make people sing just with a minute of their voice. So go check it out. Health, again, I think AI is going to be quite big in that. The most exciting thing I've seen in that space is AlphaFold 2. If you must have heard of it, it's from DeepMind, which won the Nobel Prize for very accurately predicting the protein structures, the folding of protein structures. They've got AlphaFold 3 now with isomorphic labs involved in there as well. And that's able to predict the structure of all of life's molecules, I think. And if you think about the implications of that, it's absolutely massive. You can solve some of the biggest problems we have at the moment, from designing new sorts of vaccinations through to dealing with cancer research and possibly finding the cure for that. So I think the possibilities are endless when it comes to that. So that's something you need to watch out for. Quantum AI, that's my personal favorite topic. I've gotten into quantum programming recently, and it's when you look at the possibilities of what you can achieve with quantum. I won't go into a lecture about quantum now, but it's a completely different paradigm of computing. If you have a traditional problem based on binary computing, that's not necessarily suited for a quantum computer. Quantum is where you have very complex simulations. If you want to simulate life, if you want to simulate entire universes, so that kind of problems are more suited for the quantum level. The most exciting thing I've seen recently is the Majorana tool, Majorana processor by Microsoft, where they've developed this topological architecture for, they say they're heading towards 1 million qubits or quantum bits on the size of your palm. So if you think about what kind of capability that is, if you take the most powerful supercomputer now, scale it to the size of the Earth, it won't be anywhere near as powerful as this quantum chip which sits on the palm of your hand. Again, there's speculation around whether it's really quantum and not, but that's not the point. The point is we are making strides towards this kind of technology. And once you get there, then the possibilities are huge. So if you want to design catalysts which dissolve microplastics, that's a big problem because you need a different catalyst for each one of these problems, each one of these plastic types. And the quantum computer it's able to do those kind of simulations. And then I want to speak about post-quantum cryptography, and there's doom and gloom about quantum is going to destroy your encryption and all that stuff. But there is possibility for post-quantum encryption as well. And then physical AI, the most exciting thing, we had the GTech event by NVIDIA, I think it was yesterday, but even before that, there's the, what's the library called? Cosmos, NVIDIA Cosmos, in which you are able to simulate an entire virtual environment, train your machine to operate in that environment, transfer it to the real world. I think that's going to have, it's going to completely change the way in which we interact with physical machines, not just in the digital realm. So those are my big bets. If you ask me, education is the center because that's going to be essential for all of it. Unless you really educate the public on how to use these systems, you can design the best systems which no one using it. So we don't want shelfware. Right, so let me get into the next bit. So these are examples of AI agents which you may already be familiar with. The first one is OpenAI, the operator agent, where it can do pretty much what a human user can do on a computer, click the buttons, do the shopping, and do all these kind of things. So that's good. This is from Microsoft, where the demo you see there is it's automating some of the back office functions, where it's taking the entire spreadsheet of new employees and then inputting that into the HR system. So you don't need to do it manually. If you have like 5,000 different entries, you don't need to waste all the time. The agent can do that for you. And the third one is from Google, Project Mariner, and that's showing an example of a sales agent who wants to perform research on these companies. So she's tasking the agents to find the best contact list, find out more about the company and the best way to approach them. So all that is completely automated. So back to the question about BDUK, which is what does all that mean for BDUK? So we are an operational entity, which means we don't beat around the bush. We have certain targets to reach in a certain time frame, and we have to reach that. So any AI which works for us has to work in production, used in anger. So how do you take that? How do you take all the hype? How do you distill all the hype and get it to a place where you have live production systems which are able to work with our data in order to achieve our corporate objectives. So the first thing we did was look at our data and say, okay, we need to build a data backbone. So we've got strategic partnerships with Google and a company called SoftServe, where we thought, okay, let's take all our data. There's Excel files, data sitting in silos. There's different versions of the truth. There's no semantic definition of it, which means if you define a concept within an organization, everyone's got a slightly different meaning or different interpretation of that based on their own subjective definition of it. We don't want that. So we want to semantify it. We want to create a semantic object which encodes the definition of what everything means in an organization, so that a machine can understand it, in addition to humans understanding it. So if you then query your semantic model, you get the same answer, regardless of who is asking the question. So in order to address all these things, we came up with this architecture called the data backbone. So it's entirely built on the Google stack. So we use the Google Cloud Platform, and we use various different things, right from data ingestion, persistence, security, fusion of the data, the semantic model, right through to when we make the decisions. So the entire thing is end-to-end. It's based on the Google stack, and SoftServe are the third-party company who built this for us, working with us, of course. So it was a one-team kind of approach where we built this data backbone. And the result of this is we now have a single source of truth. Everything is semantically defined, and all the data is stored. And you can have data as a service, which means it doesn't matter if you're technically inclined or not. You can use the data. You have a single point of entry for your data, and that's where AI comes in. Because if you're not technical, you don't know how to use SQL, for example, or write an AI agent. You need a way to interact with your data. Conversational analytics could be one way of doing it, and that's where the power of AI comes in. Because if you've defined your semantics properly, you can then add on AI services on top of that. So that's how it looks like once you've implemented it, and you can see all the different technologies there. And next we come to semantics. So we have this concept called UPRN, which is a unique property reference number. So which is a unique ID for anything in the UK which can be connected to the internet. So how do you define what a UPRN is? So you need a single definition which is true for everything in BDUK. So those kind of things you can define in semantics, and you get knowledge graphs and all that. I'm not going to go into that. We have limited time. But the other thing we do in BDUK is we show, don't tell. I thought I would do a live demo, but then I thought, why do one live demo when I can have 3 or 4 demos for you? So I've recorded some demos. My data team has done some recordings of demos, and I'm going to show you some of them. So this is the semantic layer in action. So if I play that, you can see that's all the data sits in BDUK sitting inside our data backbone. And then you'll see that we have defined the semantics behind it. What does each concept mean? So if there's an AI agent, how does the AI agent know what each of these concepts means? So that's what the semantic layer defines. So this is the back-end boring stuff, but it's the most important stuff because that's what makes it work. So if I go to the next one now, yes, you've defined your semantics. Now you can converse with your data. So this is an example of Looker, where you can simply drag and drop your data buckets you want to interact with, and you can ask questions of the data. So you'll see an example there from the supplier returns, how many were approved. So it knows, the next thing it does is it takes that, it contacts the semantic layer to see what these different terms may mean. It then converts your natural language query into an SQL query. It goes to the data backbone, queries for the data, returns it back, and then sends it back to the user interface in a way a human can understand. So all that is done seamlessly because we've got our data sorted. The next thing we can do is predictions, because we've got all this rich data sitting in the backbone. How can you define your intervention strategies based on the data you've got? So what's going to happen in the next 3 months? So this kind of predictive capability is also possible. We are experimenting with it. This is early prototype, but it's showing some really good results, much better than the older predictive methods we used to use for forecasting. The machine learning method, even using a bog standard machine learning algorithm taken off the shelf, is performing much better already. So it's showing great promise. So that's showing commerciality prediction. Where are the suppliers unlikely to go in the future? We also use it for other mundane tasks. So lots of people get PDFs, invoices, and all these kind of things. So Document AI provides agentic service again. So we're using that here to automatically extract key bits of financial information from Document AI, ingest it automatically into our data backbone. So you eliminate all the manual workarounds which go with that. No one wants to do that. So automate all of it. Automate the hell out of it. So that's our motto. Automate the hell out of it. So in terms of other stuff, we are based on the Microsoft 365 platform, and we get Copilot. So Copilot allows you to do lots of interesting things like document summarization, writes your speeches, creates PowerPoint presentations, all sorts of things for you. What it also does, you can already create agents within that. So this is an example of an agent created by the transformation and change team. There's often questions asked within the organization to say, okay, what are you going to do? What does change mean? I've got this new idea. How can I implement it within BDUK? You have to then go to the change team. You have to go through different board structures for that. And then you follow the change process. You go through many different gates, and then you implement your change. So this agent allows people to ask all these different questions instead of adding endless amount of meetings. You can just go to the agent. You can ask your questions. You get your answers. And then you go from there. So saves a lot of time, lots of productivity. This is just one example. We have several such agents running within the BDUK ecosystem, in addition to all the Copilot stuff. So there you go. So it's running there. So who is the best person to talk to if I want to suggest a change? All this data is grounded as well, so it's not hallucinating. So we've enabled grounding of the data, which means it only takes the knowledge from the documents we've provided to it. So it bases it on that. So that's the way to minimize hallucinations. Right, so what you have seen so far is we've shown examples of data ingestion, in this case from PDFs. We do lots of other data ingestions as well in an automated way. Agents for interacting with information from SharePoint. I think with some of the new capabilities in Microsoft, you don't need Copilot. If you have SharePoint, you can automatically create agents. Conversational analytics, speak to your data like you would with a human. So you don't need to have technical expertise in order to speak to a human. It is now possible to query your structured sources, no matter how complex they are. If you get your semantics right, you can query it and speak to your data. So this is particularly useful for BDUK because we have people called local delivery leads who go out to the places to almost do a recce. So imagine a local delivery lead who is out in the field and they're in a postcode. They go to their phone, start speaking to their phone saying, okay, I'm in this particular postcode. What's happening here with regards to broadband coverage? Is it even worth investigating? So that query now gets translated into SQL, which goes to our data backbone, returns the answer in a way they can understand it. So that's how you make it real. It's not flashy, it's not sexy, but it works. So that's what we want to do. Predictive modeling, again, we see a lot of promise in that. And of course, I've spoken about semantics enough. My PhD is in semantics, so of course I'm going to bang on about it again and again. But that's very, very important. And lastly, these are my key takeaways, which is forget about the hype, I would say. Instead of jumping head first into, yeah, we want to do some AI, I would say, look at your data first. Have you sorted your data model? Build a data backbone before you do anything else. AI is also not the one fix for all problems. So when we first started, we started with the premise of AI is the solution, where is the problem? So that's a completely wrong thing to do in terms of what the lessons learned from us. Talk about what are the problems which exist, technology agnostic. So what is the problem you're trying to solve? And then go from there. You'll see many of the problems could be solved by data science techniques. You don't necessarily need AI for that. But where you do need AI, you can then do that. Fast fail approaches, we've tried this quite a bit, which is good. Before making huge investment decisions, try the fast fail approach, and then if it fails, it fails. If it works, then go forward with it. And then get your semantics right. That's absolutely essential. So as a gift, as a data gift for you, we've made loads of our data open source now. So it's available for anyone to go and download. That's the link for it. You can just go and download very high quality data onto your computers and create cool apps, AI systems, anything. So at the weekend, I was getting bored, so I just created an agentic AI application with this using a RAG-based model. So I just used LangChain and DeepSeek, which is open source again. So completely running on my local computer. It uses a RAG-based agent in order to take queries from me in natural language. The agent invokes DeepSeek. DeepSeek retrieves the answers, and then you get back to the results. So it took me about 2 hours to create the whole end-to-end system. That's the power of having data as open source. So you can try it as well. So feel free to try it. Use our data. I'm going to stop there now. I don't know how long that took, or okay, on the dot. Okay, great, thank you.